Forces long response questions. Question 1. So I'm going to remember to cub my question. So I'm going to read it first of all quickly. Figure 1, okay. What? So it's asking me, the question is, what is the weight of the object in figure 1? Figure 1 is the Newton meter, okay, and Newton meter measures the weight. So it's asking me just to read that off. It's only worth 1 mark. So it's just going to be a straightforward question. So that's a 5, that's a 6, and it's halfway in between, which means it's 5.5 newtons. Okay, and I'm also checking there the units of this in newtons, so it's measured in newtons. Right, next bit. Okay, a student carried out a practical to investigate the extension of a spring. Write a method the student could have used. So it's asking me to write a method. It's finding out the extension of a spring. Remember, the extension is the increase in length. So how much does it stretch by? And it's practical. It's worth 4 marks. So I'm going to use my cub again. Remember, cub. So I'm going to circle command words, underline key info, and put in bullet points. So 1, 2, 3, 4. At least 4 for this. Now, quite often with these sorts of questions, it might be easier to draw a diagram to help, to imagine what's going on. So I'm going to do that. So I'm going to have a clamp stand over here, and that clamp stand will be holding a spring, like that. Okay, that's the first thing. What else do I need? Well, I need to measure the length of that spring. So I'll have a meter rule, and I'll use another clamp stand to hold that in position, and then I'll measure what that says. That's a symbol for an eyeball, by the way, a triangle with a semicircle in it. I'll measure how long that spring is. That'll be the first thing. Then I'm going to add some weight to it, and it will stretch, and I'll measure using the meter rule again how far it's stretched. Okay, and that distance it's stretched there will be the extension. So that's its extension. Now obviously I'm just jotting this down really quickly, just so I've got a rough idea of what it is I'm doing. So I need to explain how I'm doing that. So the first thing is I would set up a clamp. All my sentences here are going to start with command words. So what am I doing? So set up a clamp stand and hang a spring off a bar. Okay, so I've got the bar there. I hang the spring off it. Next, I'm going to set up a ruler using a clamp stand. Next to the spring. Okay, so that's the spring, that's the ruler set up. Then I'm going to measure, or I'm going to record length of spring with no mass on it. Okay, so that's that bit done there, so I'm happy I've done that. Next, I'm going to add mass. Add mass to spring. And if we need more bullet points, that's absolutely fine. So I'm going to add mass to the spring. I'm then going to record new length of spring. And the last thing is extension equals original length minus new length. Okay, so that's how you'd can get full marks for that question there. If you put a labelled diagram, and it's probably a little bit clearer than mine, if you've got a labelled diagram, you actually labelled you drew it a bit bigger and you labelled what bits there are, that may well get you marks as well. Okay, you will get more space than this in the real exam, but that's fairly straightforward, 4 marks. Right, let's look at the rest of question 1. So what could be done to improve the accuracy of the investigation? So the accuracy is about avoiding mistakes. That's what accuracy refers to, about not making mistakes. So what could help you here? Well, the stronger spring in the practical, so I'm just looking through this. Use a pointer, well, that's a possible. Use a stronger spring, well, that's not going to help you avoid mistakes. Use a new spring between each reading. Well, it's unlikely that that's going to avoid you making mistakes either. Make sure the spring is stationary before measuring the length. Okay, that's really important, isn't it? Because if it's bouncing around, then that's probably good, that will affect things. Use a longer ruler when measuring length. Well, it doesn't really matter, to be honest, what length ruler you use, provided you're using it properly. So we're looking here, I haven't covered this question either, I really should have done. So what could be, it's a what, and it's also tick 2 boxes. And accuracy was a key word here. Okay, so I'm looking for 2 things. It's worth 2 marks. I've underlined the 2. That's a reminder to me to tick 2 boxes. It's frightening the number of students that would only tick 1 box for this particular question. Okay, and lose a very straightforward mark. Last question, question 1 that we're going to look at. The spring constant for the spring in the above table is that. Calculate, so it's a calculate question. The work done, and I've got to use the correct equation from the physics equation sheet. Okay, so it's calculate the work done and stretching the spring until the extension of the spring is 5 centimeters, and the spring constant is that. So I've got spring constant, work done, and extension. So if I look in my physics equation sheet, and this sort of question could well come up again. Okay, the expectation is you still get to use the physics equation sheet. I'll find the correct equation in just a moment. I'm going to remember here that I have to use every. Okay, every will help me make sure I get all the marks for this question. So what we find, the correct equation, I'm looking for something that's got work done, maybe, hopefully, extension of the spring constant. Okay, I won't find work done, but what I will find is another form of energy, which is elastic potential energy. So another store of energy, another term for energy, equals 0.5 times the spring constant times extension squared. Okay, so extension squared. Okay, so that's the equation I'm going to need. I'm just going to so I've done my equation, I'm going to write the values now and convert. I notice it's worth 3 marks. So I'm going to write the values. What have I got? I've got spring constant, which if you know these, it helps. That's K. We know that the extension here is X, and work done in this case is going to be the elastic energy. So work done. So I know that K is equal to 20 newtons per meter. They're normal units, that's fine. I know that the extension equals 5 centimeter. Centimeters is quite an unusual unit. We don't usually use centimeters, and I've got meters here, so I'm going to convert that straight away into meters, which is 0.05 meters. I know that the number of meters is always less than the number of centimeters, so it's got to be a divide. And I'm going to then put those numbers into my equation. So I get the work done, which is the elastic potential energy, 0.5 times spring constant, which is 20, times by 0.05, remembering to square that. So you get a mark for the conversion here. You'd also get a mark for substitution here, and the last mark would be for calculating the answer, and the answer comes out at 0.025, and they give you units already. So in terms of rearranging and solving, I don't need to rearrange, I just need to solve it, and there's no units to do as well. Okay, again, you get more space normally in the real exam for that. That's quite a squished up answer. I hope that was okay. Right.